Hello friends. So in this video, we will discuss the same RC circuit but with a different input excitation. Here we are using the pulse input with a means proper repetition. What mean to say the square wave we are using here. Okay. So this is the lecture 7 of our this basic electrical circuit course where we are continuing with the RC circuit that we are seeing with a different input at a time. Okay. So the same RC circuit we have started with the different inputs from very step input to the pulse input with the condition of T naught much greater than RC and T naught much less than RC. We have seen this thing in the previous tutorial video solution as well. Okay. Now in this circuit the three conditions are there. T is much greater than RC, T is much lesser than RC, and T is equal to RC. So simply means this T is nothing but a time period of this wave or whatever we are giving the input here, and RC is the time constant of whatever you say charging or discharging, because in this circuit charging and discharging time constants are same. Okay, so input is given like your lower is 0 and high value is 5 volt. Okay, so we will analyze the circuit one by one. And what is the problem statement? Problem statement is a plot the output voltage and capacitor current. So same thing that we are continuously doing is output voltage and this capacitor current we have to plot. Okay, so we'll see this discussion one by one. So first I'll consider the case where we are seeing that case 1 where your T is much greater than RC. So what it mean to say, as your time constant is very small, so capacitor will get enough time to charge. Okay, so let's say when there is a excitation is applied, just I am looking around T equal to 0 positive or 0. What is happening there? Just a step is applied. Okay, T equal to 0, a step is applying, and after that it is staying for a long time because RC is much smaller than the T. So of course we can say one thing, we can also say T is much greater than RC by 2. So RC by 2 is a time when your input excitation is changing its position from high to low. Okay, so it is the 5 volt 0. So this is the time which is called a T by 2, and after that my input excitation is coming from 5 volt to 0 volt again, and after the T it is again going from 0 to 5 volt. Okay, this is my T. So we have to see, and this is my T equal to 0. So around T equal to 0, it's just like applying a step input of the 5 volt. And after that, the 5 volt is applied for a very long time because this T by 2, or sorry, better to say here, T by 2 is much greater than RC. This is the condition. Our condition that I have written is not that I want to write. Okay, so it is not here. It should be like T by 2 is much greater than RC. I should write here T by 2 is much greater than RC. Okay, so what we can see from here, that the capacitor should charge properly. Now I will not explain the step by step what is happening, but yes, you can say what is the IC 0 positive. Just my capacitor is shorted, so it is nothing but 5 by R current is there. So again, the slope at that point is what? Slope at 0 positive for the capacitor voltage is 5 by RC. Okay, so it will have enough time. So I can say tau is my what? RC. So what to speak of T settling? T settling is your nearly 4 RC, or I should say 5 RC, which is a 5 tau or 4 tau. So it is also much smaller than the time what I call the T by 2. So actually I will say my capacitor will get enough time to charge. Also the same thing will happen when we are discharging the circuit. So I can draw this circuit here only. Okay, so in a very short time it is charging, and after that it is staying at this, and with a short time it is discharging and it is staying here, again it is charging and is staying here. So this phenomena is happening, and some sort of output that we are getting is this, is mentioned in this color. Okay, so this is the output that we are getting, that I call the VC, or also I should tell is V out. Okay, so this is the nature of the output voltage. What to speak of current? Current is simply when we are charging the circuit, then current is starting. The initial value of current is this. Where is the initial value of the current? Initial value Once my capacitor is charged, IC will be what? IC will be IC at infinite, or mean to say T by 2 would what? Capacitor is fully charged, because capacitor charging time is very less, so it is charged very earlier than this T by 2. So this value I will call it as 0. So infinite, this T by 2 is behaving as the infinite for my charging phenomenon of the capacitor. So it is 0. What is exactly happening? My capacitor current is starting from 5 by R and ending sooner at 0, and after that it is staying for the 0 at the long time. And after that, what will happen when no excitation is there after T by 2? What will happen? So, okay, so this is the till the T by 2. And what will happen at T by 2? At T by 2, what is happening? I would say at T by 2 plus, my excitation is not there. So, this is R, this is moved to 0, and capacitor is charged to what I call to Vod was 5 volt. Okay, so capacitor is charged to 5 volt. Now I have to see the IC and V. See, VC we have seen. VC is nothing but V out, which has only the resistor across it, so it will discharge to 0, because discharging time constant RC is much lesser. So this is called VC or V out, which is 5 volt around T equal to T by 2 or T by 2 positive. Okay, so it will discharge, and the current which was I have taken here IC. So IC what? IC at T by 2 plus will be what? Minus 5 by R. Okay, so slowly as my capacitor is discharging, slowly with time this IC nearly T will what? It will be to 0. Okay, so slowly it is coming from minus 5 by 2, sorry, minus 5 by R2, minus 4 by R, then minus 3 by R at some instant, minus 2 by R at some instants. So slowly it come down to the 0. Okay, so what is happening? This discussion we have seen many times, and how exactly it happens. So what is there? Let I should draw my input first. This is my input, 5 volt, then it is T by 2, then this is T by 2 to T. Okay, so this is some sort of input here. This is T, this is what? 3T by 2, this is 2T. Okay, so what is the behavior of input? The capacitor current. The capacitor current will be what? It is initially the 5. First, I should say that the volt the current value is 5 by R. So I am just drawing from here. It does not mean that it is 5. It is 5 by R. Okay. So for the current, I should say this node is 5 by R. Okay. So at T by 2, what is happening? I should remove this timestamps so that we can draw it properly. Okay. I will remove these timestamps. Okay, so here what is happening? It is reaching to minus 5 by R, then again to 0, again to 5 by R, again to 0, minus 5 by R to 0, again to plus 5 by R and to 0. So this is your current plot. This is my current plot. This thing we have seen that T is much greater than RC. Also T by 2 will be much greater than RC. In fact, T by 2 is much greater than 5RC or 4RC, which is nothing but the settling time. Okay, so these things we have to keep in mind, and we have to plot accordingly. Okay, and voltage we have seen. If I draw it completely, this is my voltage. It will also repeat like that only. Okay, so it is what? It will repeat like this. So what is the final voltage and current plot? If I draw in the one diagram only, then we can see if you draw the only single diagram, and this is a complete plot. Okay, so this is my scale, time axis. So input is what? 5 0 5 0 5 0. Okay, so this is my nothing but input V into 5 volt and 0 volt. So what to speak of output? Output voltage or the capacitor voltage is from 0 to 5 volt, 0 5 volt, again 0. Sorry, it is drawn incorrectly. Okay, yes, so it is to 0, then it is to 5, it is to 0. Okay, so actually it is happening in very short time. This time, that is I call settling time, which is nothing but 4 tau or 5 tau, is much less than this t by 2. So actually I can say it is setting, it is reaching to 5 volt in very short time. Okay, a very short time. This is very small. But for the visibility viewpoint, I have drawn like that. It is properly charging and discharging, so it can be visible. Okay. The same thing for the current. Let's try to remove it. So what is happening for the current that we already have seen? Something like this. Okay. So this is the current. So what do you mean to say? This point, don't consider it as a like of 5 volt. It is my 5 by R current. And this peak is nothing but minus 5 by R. Okay. So this is the complete plot. So the case we have covered here is the case of T is much greater than the RC. Now let's take the T is much lesser than the RC. The case 2, it means what? The time constant is very larger than the period of this signal. Okay, so T by T is also much lesser than the RC. So what will happen exactly? So actually the settling time is very much greater than this time. 4 RC or 5 RC is very greater than this T by 2. Okay, so what will happen then? First I should draw the circuit here. So this RC 0 T by 2 5 volt V out I see. Okay, so I will say RC is very greater than T, or RC is very greater than T by 2. It simply means the capacitor will not charge in the time where what we are giving to this for the charging. Okay, so let I should draw it here. So let in this time just after 0 capacitor is shorted is fine. So initial current is again what I should say, what should be the initial current at t equal to 0 positive. T equal to 0 positive, first of all we are applying a sort of a step here. So capacitor is shorted. Capacitor is shorted simply means the IC 0 positive is what? 5 by R. So initial current is that only. Okay, but the point is that will my capacitor will charge in this t by 2 time? No, because it is not enough time to charge. The time constant is much higher, so the settling time is also much higher, so it will not charge the capacitor fully. Okay, but I'll say it will charge to some extent. Let's say it is charging to, so I should draw it properly. Okay, so this is my 5 volt. So it will not charge to the amount that we are required of. That is the final value. Okay, so this will charge, let's say, to some sort of value. let I call it for the time being, it is charged to 1 volt, let's say. Okay, so if it is charged to 1 volt, then what is happening at t equal to 0? At t equal to 0, this is my time t equal to 0. Sorry, this is my time t equal to 0, and this is the time t equal to t by 2, and this is the t. So what will happen at t by 2? At t by 2, my excitation is removed. So the circuit after t by 2 is what? I see t by 2 plus is going to what? It is negative value, but was minus 1 by R. It is not minus 5 by R. Previously, when it was fully charged, this value of current at t equal to t by 2 positive was minus 5 by R, but now it is a minus 1 by R. So initial slope is lesser in this case, or I mean to say simply, it will discharge, but very slow rate, because the time constant is much means larger here. So what we can say, from t by 2 to t it will discharge, but the initial value of the current is minus 1 by r. So slowly it will remove, or it will be decreasing, like let's say minus zero point 0.9 by r. So it will slowly go like this, or let's say, so this point, or I mean to say, the capacitor has not much time to discharge its value, so it will reach to some value which is lesser than this 1 volt. Okay, so it will discharge, but not exactly the complete discharging will happen here. Okay, so it will discharge to, let's say, this point is nothing but zero point 0.8. Okay, so let's call this value was voltage as zero point 0.8. Okay, so let should I call this node as zero point 0.8. Okay, so my capacitor is discharged from 1 volt to zero point 0.8. Now what is the initial value of the current here? Because my capacitor is already charged at zero point 0.8. Okay, so what is the current at t equal to t positive? Actually, the current here will be what? My 5 volt is again applied, minus what is the stored value divided by r. So it comes to be what? 4.2 by r. Okay, so now the initial current is different from the case when it was 5 by r. So this charging slope initially is slower. Means the charging slope at t equal to 0 positive is lesser than the charging slope at t equal to 0. Okay, so it has some lesser slope. So it will reach to here, somewhere here. Okay, so previously, as in this time window, this is in a 3t by 2. So previously, what was happening? Previously, it was charging in the from 0 to t by 2. It was charging from 0 to 1 volt, let's say. So here it will charge to lesser than this amount. So this amount change between t equal to 0 to t by 2 was 1 volt. So what is my point here? My point is that because here initial slope was larger, so the amount change we have seen 0 to 1 volt, let's say, but here this amount will be changing but lesser than this 1 volt. So let's say it is changing by zero point 0.8 volt. Okay, so let this change happening here is zero point 0.8 volt instead of 1 volt, because 1 volt was happening because of the larger initial slope. So this some larger charging rate initially, but here the charging slope is different, which is nothing but 4.2 by r. So what will be the change? I am expecting that the change should be pointed. So it was obviously already at the pointed, 1.6 volt. Let's say the 1.6 volt. Okay. So same mechanism will happen, and after that you will see what is the discharging slope at, what is the IC value at 3t by 2 plus. I have seen that my capacitor is already reached at 1.8 value. So what it should be? It should be minus 1.6 by r. So now the slope is more. So what we can say, what previously change was happening between t by 2 to, this is the point, what change was happening here from t by 2 to t, how much change was happening? Change was happening like 1 to pointed, means it was happening to minus zero point 0.2 volt. Okay, but here from 3t by 2 to 2t, the initial slope is more, which is nothing but minus 1.65 r. It means this delta change will be larger than that. So let I should say it is minus 0.4. I'm just taking the number so that you can have the idea. So minus 0.4 simply means from 1.6 it should reach to 1.2 volt. Okay, simply 1.2 volt. What I mean to say, if I should draw here neatly, so you will see what is happening there. So initial slopes are very important to keep in the mind. 0, 5 volt. So I'll just take few numbers. So let's say initially it is charged to 1 volt. This I call the 1 volt. So the initial slope here was 5 by R by C. Okay. So the initial slope was that I call the S1. This is that 0 positive is 5 by RC. And after that it is minus 1 by R. So let's say it is reaching to 0.8. And after this is the 0.8. So after that initial slope is different. Here the initial slope is what? That I call a S2. This is a T, a positive. Okay. So it is what? Okay. So at T positive it is 4.2 by RC. Okay. So it is different. So amount change here I have considered the 0.8 only. So it is reached to 1.6 volt. After that we are seeing that discharging slope is increased. So amount changes more than this amount change. What is this amount change? The amount change in this T by 2 to T is what from 1 to 0.8 means so minus zero point 0.2, so minus zero point 0.4 I am considering here. You can see the previous slide also. So this node voltage is nothing but 1.2 volt, and after that we have seen the initial slope, which is nothing but for this time instant, let I call the 2t positive. Here it is 5 minus 1.2 by RC, which is nothing but 3.8 by RC. So it is still changed much. So the amount changing, delta amount change here is lesser. So okay. So previously the amount change of 1 volt. Here I have considered the amount change of here the amount change here was like I should say here. Okay. So here the amount change of 1 volt. Here the change in amount was 0.8 volt. Here let's say the change in amount is 0.6 volt something else. Okay. So it will reach to 1.8 volt. The same thing is happening here. Here the amount change is what? Like 0.2 volt minus. So here is what I've considered minus zero point 0.4 volt. So similarly, we can consider here the minus zero point 0.5 volt. So it will reach to somehow 1.3 volt or something. So these are just random numbers. You can consider whatever. So you will see the output is reaching to the steady state but very slowly. Okay. What we can see observation is that output voltage or capacitor voltage is trying to reach the steady state value of of 5 volt what in many cycles. Many cycles simply means it is slowly charging. So some sort of this mechanism will happen for the CT. It is slowly going here, then reducing, then increasing, then reducing, increasing, reducing, increasing. So slowly it is reaching to 5 volt. Let's say this is my 5 volt amount. Okay. So instead of directly reaching to 5 volt in the short span of time, whatever the case we have seen, where the charging time was very less, it was reaching to 5 volt very early, but here it will reach the 5 volt, but it will take lot of time periods. Okay, so here tau very small, so 4 tau is small because of they are considering 4 tau because of settling time. Okay, so here also here it will what tau is very large, so 4 tau is also very large. So in this case also my output is reaching to the 5 volt, but it's taking a lot of cycles to reach there. Okay, so I think I could clear my point here. So for the current, you can see when the initial current was what, like initial current is of 5 by hours, and after that it is slowly reducing. And when at t equal to t by 2, I have reached. Okay, so I should use the pointer here. Okay, so what we are seeing, my voltage here is t equal to 0 means voltage is 0 volt. So the initial current is what 5 by R. So 5 by R means somewhere here we will start with the current, and after that I will see at t equal to t by 2, my voltage of capacitor reached to 1 volt. So what is the current there? At that time the current is nothing but 5 minus, because 5 means this voltage minus this voltage, capacitor voltage, which is 1 volt at t by 2. So it is 5 minus 1 and 4 by R. So the current is 4 by R. And after that, what we are seeing here, the current, what should be the current at t, sorry, time at t. So at time t, okay. So one more thing that I should clear here. Okay, here the initial current here what means 5 by R, and after that at T by 2 we are reaching at 1 volt. So the current is reaching to 4 by R, and after the 4 by R we are seeing that at T equal to T by 2 plus my input excitation is removed. So that current what is present here is nothing but the 4 by R, it will be negative because there is no excitation applied here. So my capacitor, whatever the value it has reached to 1 volt, it will start backing this voltage only. Okay, so what is my mean to say, what I mean to say, I should tell you clearly. So this is the R C. So I'm just taking 2 cycles 0 T. Okay, this is a 5 volt input out. So for the current T equal to 0 positive, what is the current? I see 0 positive is what? 5 by R. I see T by 2, or I should say T by 2 minus. A T by 2 minus or T by 2 or T by 2 plus. If volt in terms of voltage, the voltage is 1 volt. So I'll say what? It is 5 minus 1 volt by R. So it is nothing but 4 by R. This is the current value. And what will happen to the current at T by 2 plus, because at T by 2 plus the voltage across the capacitor is only 1 volt. So what is the condition at T by 2 plus positive? Okay, so this is the R, this is a C, and this value is reached to 1 volt. This is the condition for T by 2 plus. Okay, so this is reached to 5 volt. What should be the current? IC should be what? Minus 1 by R. Okay, so from 4 by R to it is changing to minus 1 by R at t equal to t by 2. Okay, so it is happening, and after the t by 2 till the t, this is the t by 2. After t by 2 till the t, what is happening now? Instead of 1 volt, this value is reaching to, what is the value it is reaching? It is reaching to 1.6 volt. Okay, here 1 volt, it is reaching here 1.6 volt. Let's say this is the 1.6 volt. Okay, so what will happen at t equal to, let I should say IC T minus. So T minus simply means there still excitation is not applied. The output is reached to 1.6 volt. So the current I will consider here is minus 1.6 by R. Okay, because output is reached to 1.6 and still my output is sorry, my input excitation is not present. If my input excitation is not present, so or I think one thing is missing. Okay, I think something is missing here. Okay, sorry. Actually, output is, voltage reached to zero point 0.8. So here the voltage reached to zero point 0.8. Here the because the excitation is not there, na, so output cannot increase. If excitation is not there, so output is not increasing. Or it is reaching to sorry, zero point 0.8 volt. So it is what, 1 volt. What is happening here? This value is minus 1.8. Okay. So this value is minus, sorry, not 1.8, minus 0.8. Okay, so minus 0.8. So these are the current values, and what will happen at IC? So just this is the flow. You understand this flow. So what is IC T positive? And at T positive, we have seen. Okay, I'll consider that T minus T positive. The value of voltage is sorry, zero point 0.8. What at T equal to T plus, we have seen the excitation is again applied. So excitation again applied. So what should be the current? 5 minus 0.8 by R. Actually, it is 4.2 by R. So this is the current. Okay. So from here we can understand some sort of the plot for the current. You can have the understanding. This is the T. Okay. So what is happening? I'll draw it. So initial the current is 5 by R. What is happening at T by 2? It is slowly discharging to this value is 4 by R, and from the 4 by R it is suddenly going to negative value, which is nothing but minus 1 by R. Okay, it is minus 1 by R, and from minus 1 by R this instant is T by 2. At T it is again reaching to some value which is minus, this is T, and here my current is reaching to the value minus 0.8 by R. Okay, on the same instant it is reaching to 4.2. This value is 4 by R, so this value is 4.2, means higher than that. Okay, so higher than the 4 volt, means 4 by R value. So this point is higher than this point. Okay, so this is nothing but 4.2. So it will reach to some sort of less value here again, and from here it will go to negative, and after that it will reach some sort of this value. From here, after that this value, so it will slowly reach to this way. It will attain the steady state. Steady state is attained after many cycles. Many cycles mean to say because my time constant is much higher. So anyway, when my capacitor will reach to, or is it when t is very greater than, I should say some value that is a t, after many cycles, my capacitor will reach to 5 volt. At that time, IC should be your 0 amp. So anyway, the IC has to reach the 0 ampere in many cycles when my capacitor voltage will reach to 5 volt. So this is a sort of analysis, very important analysis that is asked in few companies in the recent years. So maybe this can be the first question or maybe the second question. In the many interviews, they expect this analysis from you people. And the time stamps are very important when time is very greater than the RC, and time is very less than RC. Okay, so when time is very less than RC is really important case. So this case is important, and time is very less than the RC. Here the analysis will matter. Okay, and T is greater than, sorry, T is equal to RC. In the case you can simply analyze. It is nothing but at T equal to RC means T by 2 equal to what we to say, with respect to RC you can see and you can plot it. So this I am leaving as a homework exercise. Third case is just a homework exercise. You analyze and you watch the video carefully, and after that you try to draw the current and voltage plots for the case third, which I am leaving as a homework exercise. Okay, so I think I could clear my point, and here it is important discussion. And just look the slopes and initial values of the currents very carefully, and from there you can have a lot of idea. Okay, so I think this is enough for this video. Thank you.